Hello everyone, and thank you for joining in again with Math with Sohn. Today we're going to be looking at intersecting tangents and secants and finding the lengths of those chords. So let's get into it. We can have a circle, and we are going to have two secants this time. We're going to put one of them here, one of them there, and this is going to be the harder version of these. And what makes it the harder version is really something quite simple. Instead of having the x on the inside as the chord length, the x is actually going to be just placed on this outside part. So I'm going to put an x here, and then I'm going to make this 5. And I'm going to put a 4 on the outside and make the inside 2. The rules don't change, but the problem, solving it, will be much more difficult. So we have the outside, the x, times both of them, and that is going to equal the outside times both of them as well. And the outsides are going to be the x and the 4, and both is going to be the x and the 5 put together, and the 4 and the 2 put together. So for the outside, for the 4 part, we'll start with the 4. We got 4 times both, well, both 4 outside and inside, 2 put together make 6. 4 and 2 put together make the 6. Equals the outside for the other secant, x, times both of them. Well, we can't really add x and 5 together, but we can represent that as an x and 5 as x plus 5. This problem will require a little bit of factoring, because when we distribute this x, we are going to get x squared and a 5x. 4 times 6, that's easy, 24. Now because we have an x squared and a 5x, we're going to have to factor. And if we have to factor, we will need this to be set equal to 0 to solve that equation. So I am forced to, because I am factoring, subtract the 24, and we get 0 is equal to the x squared plus 5x minus 24. Now most of these, because geometry is going to be an easier factoring problem, so you just have to think of numbers that will multiply to equal the negative 24, but add up to equal 5. And sometimes it is helpful to list out just things that multiply to 24. That would be 1 and 12. Not 1 and 12, what am I thinking? 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now out of those, which ones where we can add or subtract, because if you add a negative number it's subtracting, can equal 5? Well, the answer to that question would be listed out very easily, 3 and 8. Can't make a 5 with 2 and a 12, you can't make a 5 with a 4 and a 6, but if you subtract 3 from 8, you can get a positive 5. So that's what we're going to put here. We're going to put the x with a positive 8 and the x with a negative 3, because 8 minus 3 equals 5, and 8 minus 3 multiplied together equals negative 24. Now these may be the factors, but the solutions will occur when we set these factors individually equal to 0. Now x plus 8 equals 0 means x will equal negative 8. X minus 3 would equal 0, you would add 3, and when you add 3, x would equal positive 3. Now normally out of these answers, one of them will not work, and that normally is going to be the negative answer. In this case it is the negative answer. You cannot have this segment from here to here equal to negative 8. So that would be what we call an extraneous solution. You just cancel it out. So a real answer, or only answer, is 3. Alright? So let's do another one. Those are a little hard. Let's do another problem. Let's do one that is a secant followed by a tangent. So it doesn't go through the circle, it skips off the circle right there. Again, what would make it more difficult is if on the outside here or here you have an x. And in this case, I am going to make this part x plus 5. And here I am going to make this 12, and I'm going to make that one 15 from there to there. So we can do the formula, which is outside times both for the secant part. This part is still outside times both. Here you don't really have anything but an outside, so that is really outside squared, or you could write it as out times out. Both of them are the same. So I'm going to start with the 12 and 15 because that's the easier part. Outside is 12 times both of them, which is 12 plus 15. It's going to end up being 27. Equals the outside squared. Well, that's x plus 5 squared. So we have 12 times 27 here. And this, you cannot distribute the squared. You have to write it as x plus 5 times another x plus 5, which will require that you FOIL. All right. So let's start with 12 times 17. That is going to equal 324. You would probably need a calculator for that. When we multiply the x plus 5 times the x plus 5 together, you're going to have to distribute the x to both terms. X squared plus 5x. Then distribute the 5 to both terms. You get another 5x. 5 times x is 5x. And 5 times 5 makes 25. So from here, you're going to combine like terms. It does have an x squared and an x. We are going to have to factor again. So I'm going to combine the 5x and the 5x. That's the first step. That makes 10x and positive 25. I again have to factor, so this needs to set equal to 0. We subtract the 325 to get that equal to 0. And we get 0 equals x squared plus 10x minus a big number. It is equal to minus $299. So we need to think of numbers that multiply to 299 but can add up to equal 10. And I don't know what the multiples of 299 are. There aren't that many. And if you've listed all of them out, you'd have 1 and 299. It doesn't divide by 2. It doesn't divide by 3. It doesn't divide by a whole lot of things. But I'm going to tell you right now that this one does, in fact, if you keep dividing by 1, then 2, then 3, then 4, then 5, then 6, then 7, and keep going up, you can get it, and it will divide by 13 and 23. 13 dividing 299 by 13, you get 23, and 13 times 23 equals 299. Not only that, but if you look at 13 and 23, if you subtract those, we can get 10. Okay, so this is just a little bit of a harder problem because the numbers were bigger, but the process remains the same. So I am going to write in my x's. I'm going to write the 13. I'm going to write the 23. In order to add to positive 10, that means that the 13 would have to be subtracted from a positive 23. So I wrote a negative 13 here and a positive 23 there. And again, these are not the solutions, these are the factors. We have to set these individually equal to 0 to get the solution. So I have x minus 13 equals 0, x plus 23 equals 0. Add 13, you get 13 as one answer, and negative 23 is the other. Now in this case, the negative answer still does not work, but there would have been a few negative answers that do, because if you just had a negative 1, well, negative 1 plus 5 is 4, and that's still a real answer. So just because you get a negative answer doesn't mean it's always going to be the wrong one. So don't just instantly assume the negative answer is going to be the wrong one. In fact, sometimes the negative answer is the correct one. In this case, 13 is the only real solution we have. And if we wanted to find out this distance from, let's say, A to B, you could plug in 13 and get 18 if they were asking us to do that. They weren't. So that's going to do it with this episode, everybody. It's only 2 problems, but they were a little bit lengthier. So you need to be very certain that you watch this over again if you didn't understand it. I would recommend looking at my factoring video and or my foiling video, because I did go through these foiling and factoring problems a little bit quickly, and that was because I had other videos for it. All right, but until next time, I will see everybody later. Bye.